this video, I'm going to describe the constructing evidence-based explanations practice in the context of the tracing carbon through the Arctic food web data puzzle. So the goal of this practice is for students to finalize new understandings, new science ideas as they relate to the investigative question by constructing explanatory models. So as part of this practice, we need to define and describe models with students, and we'll look at an example of an explanatory model together as a class. Ask students to co-construct a gotta have checklist. So this is a list of ideas, concepts, and evidence that everyone agrees needs to be in an explanatory model for the investigative question. And then students will construct models, these explanatory models, either individually or in pairs. And so again, the first part of this practice, now that we've gathered some evidence through an interactive reading and a data interpretation, data analysis task, it's time to construct a final model for the investigative question. How might the decline in sea ice affect Arctic organisms, large and small? But what should be included in a final, and what does a model even look like? We need to spend some time together to look at an example and talk about that. And so a final model, a scientific model, scientists use models, included annotated sketches like what we'll produce here in this data puzzle, to visualize explanations to questions they're investigating. So included in scientific models, we need to include relevant parts and components. We need to connect those different parts using signs and symbols. These can be things like arrows or zoom in windows or text boxes or partitions. And then we can include any evidence that we may have. For example, evidence in the form of data from the pie charts we were analyzing earlier. And so before we ask students to think about the parts, the connection between parts, the evidence for the Arctic tracing carbon through the Arctic food web data puzzle, we want to give them a different example, one that they may be more familiar with. In this case, this explanatory model relates to the Marvel movie Black Panther, and is a representation of why the Black Panther gets stronger after being punched. And so we're having students identify these different parts, connection between parts, and any evidence in this model, something they might be familiar with, before they go and are tasked with constructing their own models. After giving students an opportunity to talk about this model, just reinforce the different signs and symbols that students can use to connect relevant parts, arrows to show connections or movement, keys to help others understand symbols in models, zoom in windows so you can see what's happening on smaller scales, among other signs and symbols. After going through that as a class, now it's time for students individually and then as a whole class to create a list of different ideas and concepts that students think need to be included in an explanatory model for this investigative question. How might the decline in sea ice affect Arctic organisms, large and small? So this is a really important task. There's a lot of information thrown at students and engaged in by students with the interactive reading and the data analysis piece. So now giving students an opportunity to figure out what are the ideas that need to be included in this explanatory model, and what evidence do we have to support those ideas and those claims. And so check out the answer key for an example of the gotta have it checklist and a final model for this data puzzle. And then students are going to use and refer to that gotta have it checklist to construct their final explanatory model. So included in this model, you got to include the relevant parts, connection, and data. And so here is the image that students will be annotating upon to construct their final models, again representing the investigative question: how might the decline in sea ice affect Arctic organisms, large and small? After students have constructed these models, we encourage you as a class to engage in a model sharing practice. A lot of times this looks like a gallery walk in classrooms, but we want to really reinforce and encourage the collaborative nature of learning and how important it is to share ideas with one another. And so in classrooms, this might look like taping up models around the classroom, or leaving models on desks and having students look at one another's models. maybe different questions and discussions come out of that. So just an opportunity for students to learn with and from one another. After this model sharing practice, we want to give students an opportunity to think about all that they've done, maybe in a slightly different context. So apply these science ideas to something we haven't already talked about or a new scenario. And so for this data puzzle, the digging deeper question has to do with Arctic indigenous people who have lived and thrived in the Arctic for thousands of years and sustained themselves by hunting and foraging. And therefore, they're a really important part of the Arctic food web. And so we want students to think about how the decline in sea ice might affect the indigenous people that call the Arctic home. And then we'll hear from the indigenous people directly about how the decline in sea ice is affecting their ability to hunt and forage with this PBS film. And after watching this film and engaging in other discussions, whatever discussions might arise from the film, that's going to conclude the Tracing Carbon Through the Arctic Food Web Date Puzzle.